Hi, this is Anu for mathschool.1 in class 9 mathematics. We are seeing rational numbers in these classes, and this part also deals with rational numbers. We have been seeing rational numbers and their decimal expansions, isn't it? In last class we have seen up to pure recurring decimal numbers as rational numbers. So now we'll continue with that. So pure recurring non-terminating rational numbers we have been seeing, isn't it? So for example, let me take 0.2 bar, isn't it? 0.2 bar, I'll write it as x, and 10x is equal to 2.2 bar. Therefore this is 2 plus x, and I write 10 minus x is equal to 2, and 9x is equal to 2, or x is equal to 2 by 9. Now if you observe this, we have got all the results. Actually in the last class we have done 0.3 bar. For 0.3 bar we got it as 3 by 9, and I have reduced it to 1 by 3, isn't it? But if you observe, 0.2 bar becomes 2 by 9, 0.3 bar becomes 3 by 9, and 0.75 was 75 by 99, isn't it? We reduced it to further 25 by 33. So if you observe, we'll have a pattern for all these numbers which are converted back to its rational number, that is p by q form. That is, if I have only one decimal place, see there is a shortcut for this. If I have only one decimal place, I just drop the bar. Without the decimal place I write the number, and how many numbers are inside the bar, that much number of 9 I need to write. Okay, then see for 3 bar it is like that, 3 divided by 9. 0.575 bar, I drop the bar and drop the decimal number point, and write 75 here, and write how many 9s are there, as much number of numbers under the bar. So 75 divided by 99, and you can reduce it to lowest form. So this is short form for finding out the p by q form for the decimal numbers, that is recurring, non-terminating, recurring, pure decimal numbers. So if I have 5.2 bar, in this case what I need to do is I split it into plus 0.2 bar, and you get 5 plus 2 by 9. Let us take the LCM, 45 plus 2 by 9, and this becomes 47 divided by 9. Do you understand? So 5 plus 2 by 9, it becomes 47 by 9. So if at all I have, see 1.23 bar, I take it as 1 plus 0.23 bar, and this becomes 1 plus 23 divided by 99, just like this. I take LCM, 99 by 23 divided by 99, and this becomes 12, 122 divided by 99. Now do you understand? How does it come? 122 divided by 99. Okay, so this I can reduce it to lowest form if it is reducible, or if it has a common factor you need to reduce and bring it to the lowest form. Now if you observe, see this 5.2 bar becomes 47 by 9. If you observe, even I can bring it easily, directly. See this, I drop the decimal number, I drop the bar, I get 52 now, isn't it? I get 52. Then what I need to do is I get 47. How do I get 47? I just need to subtract this 5. See, if I subtract 5, I get 47. That is 47 divided by 9. See, isn't it easier? So like that I can do, but this is very easy for us. Do it as much as possible. Going by the rule is more easy for you, or it will be more clear for you without any mistake. So you can follow this. Okay, split the number, split the whole number part and the decimal part, and do it as usual. So this result can be written directly, as we have found out a rule for this. So we can write it directly and bring it. Okay, do you understand? So this is how we do for pure recurring decimal numbers of rational numbers. Okay, now we'll be seeing mixed recurring. This is pure recurring, and now we'll be seeing mixed recurring. Now what do you mean by mixed recurring? Pure recurring means it has it has decimal numbers repeating decimal numbers in the decimal places. Okay, that is the numbers like this are pure recurring. But if I have some number without recurring and then the other numbers are recurring. So here I have 2, that is non-repeating number, and have the rest of the numbers repeating. If I have like these numbers after the decimal point, then those are called mixed recurring. That is, you have non-repeating numbers along with the repeating numbers. So in that case, how do I convert them into P by Q form? So let us see conversion of mixed recurring non-terminating numbers to P by Q form. That is, let us take 2, 3 bar. Okay, so now let us observe this 2 alone is non-repeating. So how many numbers are non-repeating after the decimal point? I should see the numbers which are non-repeating after the decimal place. So there is only one number here which is non-repeating after the decimal point, isn't it? So I multiply this by 10. Okay, so let us take this to be x, and I multiply this with 10 because I have only one number. So I add only 1 0 to 1 here. So 10x is equal to 10 into 0.23 bar. So I am separating the non-repeating number. So that is my aim. So I have got 2.3 bar, which is 2.3333. I can write it like this. Okay. Now what do I do is I subtract x both sides. 2.333 minus what is x here? 0.233. Isn't it? Do you understand this step? I subtract x on both sides. There previously I have done the same. I am doing the same, but there I have subtracted directly because I get the same x there. But here I have separated the non-repeating number here. So to simplify my process, to understand it better, I subtract x on both sides. Here I subtract it as x, and I take the value of x here and subtract it. Okay. So the next step is subtraction of x value. So 2.333 minus 233 will give you, see, 2.333 minus now this is 2.1 for me. Okay, this is 2.1. So I've got directly 9x is equal to 2.1. Okay, so that is 9x is equal to 2.1, or x is equal to 2.1. I can write this as 21 divided by 90. Do you understand? So this becomes the P by Q form of 0.23 bar. Do you understand? So this can be reduced still further as 7 divided by 30. Do you understand? So this is how we convert mixed recurring non-terminating rational numbers to P by Q form. So do you understand? So I have subtracted this 10x from, subtracted x from 10x, and I have subtracted the same x 0.233 bar with 2.3 bar. Do you understand? How do I get? So this is what I get here. So 2.1, that is 21 divided by 90, which gives you 7 by 30, and this is your P by Q form for this mixed recurring decimal expansion. Okay. Now we see another example. 0.123 bar. Okay, now if you observe here, you have two numbers after the decimal places. So you need to multiply this with 100. So 100x is equal to 100 into 0.123 bar. So what do? I have separated, I am doing this for separating the non-repeating numbers. So 12.3 bar, that is 12.333. Okay, do you understand? Now I subtract 100x minus x. Here 12.333 minus x is 0.1233. Okay, so if I subtract this, I'll be getting 12 minus this 333. So what do I get? I get 21. So 12.21. So that is 99x is 12.21, which is equal to 12.21 divided by 99. That is x is equal to 12. Or I can write this as 1221 99 into 100. So this divided by 100 will give you 12.21, isn't it? So 1221 divided by 9900. So this is my P by Q form. This is my P by Q form of 0.123 bar. So if at all you can divide it by the same factor, or if you can reduce it to lowest form, you can reduce it to lowest form, and you can you should reduce it to lowest form. So this is how we convert mixed recurring decimal numbers into P by Q form of the rational numbers. Now do you understand? So this is what we have done until now. So we have seen rational numbers, terminating rational numbers, and non-terminating rational numbers. And in non-terminating rational numbers, we had pure recurring and mixed recurring, and there is another type called non-recurring. We will be seeing it in the next class. So this class we saw about mixed recurring rational numbers, and we have converted the mixed recurring rational numbers, that is decimal expansions, to rational numbers in the P by Q form, and they need to be reduced to their lowest form so that they don't have any common factor. Okay, so do you understand? So this is up to this class. We have done with this. So in the next part we will be seeing the non-terminating, non-recurring numbers. Non-recurring, that is, they don't repeat itself. So special numbers are there. There are some special numbers which cannot be represented in the P by Q form, and those numbers are called irrational numbers, and we'll be seeing it in the next part. So until then, it's signing off. Thank you.